I hope you are doing well. So in the previous video, I solved some questions on units and measurement. Okay, so in this video, we'll continue solving more questions. We'll solve these questions and even the next page we have some questions. Okay, so since we solved question 1, we go direct to question 2. So for question 2 rather, we have to convert 50 newtons to the equivalent CGS system. So remember, just in the introductory video, we talked about systems of units. Talked about the CGS system of units, the MKS and the FPS system of units. In addition to that, we even talked about the international system of units, or simply SI units. Okay, so here we have been given, so we have question 2, we have been given 15 newtons, which should be converted to CGS. So we are converting 15 newtons to CGS. So just a quick revision. C stands for centimeter, this is gram, that is second. So 15 newton, let's break down this one. What fundamental quantities make up a newton? You know that F force is equal to mass times acceleration, and this newton is simply mass, which is kg, then acceleration is what? Meter per second squared. So these 15 newtons can also be written as what? 15 kg meter per second squared. So if you check here, we have mass, length and time. Mass is in what? Mass is in kg there, so we can say k, then length in meters, m, then time in seconds, s. Yeah, so this is the MKS system of units. So we are converting from the MKS system of the unit to CGS system of units. So how do we do that? Remember, so let's compare. This mass in MKS should be what? In kg. Then their mass should be in grams. Then the length, we have meters, it should be in centimeters. Then time, second, time should be maintained. So the aim here is to simply convert kg into grams and meters into centimeters. So you agree with me, I can write this 15 as 15 kg meters, 15 kg meters all the way up to there, then over the 1 second squared which we have. So we use the chain link conversion. Say multiply by, so the m should be converting kg then meters. So let's start with kg, which will be converted to what? Gram there. Okay, so we'll do that. We have to get rid of the kg. So say kg and we want grams. We do that because kg are supposed to cancel. So you know that 1 kg gives us what? 1000 grams. By doing that, kg and kg there cancels, or remained with grams. So multiply by, we should also get rid of that m by introducing centimeter. So we know that m there, so that m and m can cancel, centimeter. On top, we know that if we have 1 meter, we give you 100 centimeters, so that m and m will cancel. Then just multiply everything you have remained with. So say 15 times that 1000, you say 15, then 1000, how many zeros? That's 1, 2, 3, multiply by 100, so add 2 more zeros, centimeter. Then centimeter, then we also have what? Gram. Actually, let me start with the gram. Gram, centimeter, then over what I've remained with down there, it's just 1 second squared. So this one finally we can write it as 15, then in scientific notation it will be what? Times 10 to the power of many zeros? 1, 2, 3, 4, 5. 15 times 10 to the power 5 gram centimeter per second squared. So we have just converted from the MKS system of units to the CGS system of units. Hope that's clear. Okay. Then the third question, get back on this side. So the third question, we are converting. So convert 5 square meters to square centimeters. That's question 3. We are converting 5 square meters to square centimeters. Okay, 5 square meters to square centimeters. So how can we come up with a conversion factor in this case? We know that 1 meter forms how many centimeters? 100 centimeters. So these are not squared, but we are dealing with area squared. So just square what you have. These linear units, square, so that you can have 1 meter squared will give us what? So 100 squared, that's 10,000 centimeter squared. So this is the conversion factor that we will use to convert 5 meter squared into centimeter squared. So let's use the chain link conversion. What have we been given? 5 meter squared, you can say over 1. Multiply by, so we have to get rid of that meter squared. So down there we should have meter squared, then on top we should have centimeter squared. What is our conversion factor? 1 meter squared should give us, that's 10,000 centimeter squared. Meter squared would disappear. Then you write what remains. We have 5 with how many zeros? That's 1, 2, 3, 4 square centimeters. By doing that, you are done. You've converted. Okay, then question 4. We are saying convert 100 liter per hour to cubic meters per second. So we have been given 100. So this is question 4. We have been given 100 liter per hour. We should be converted to cubic meters per second. So meaning liters should be converted to cubic meters, then hours should be converted to seconds. So let's proceed. So there's a conversion factor which we should know. So for what's the relationship between liters and cubic meters? You know, it's volume. Now if you have 1 cubic meter, you simply have 1,000 liters. So 1 cubic meter gives 1,000 liters. Take note of this. 1,000 liters gives 1 cubic meter. So here we use chain link conversion. We have 1,000 liters over that 1 hour. They multiply by, so we convert liters into cubic meters, and this is our conversion factor there. So see, over, so I want to get rid of the liter, should have liter down on top cubic meters. And if you have 1 cubic meter, you actually have 1,000 liters. So liter and liter will cancel, will remain with what? Cubic meter there. Then you should also convert hours into seconds. Okay, so should get rid of hours, meaning should have hour on top, then minute first. So convert to minutes, then to seconds. Then we know that 1 hour gives us what? It's 60 seconds. So 1 hour gives us 60. Sorry, 1 hour gives us 60 minutes, not 60 seconds. 1 hour 60 minutes. Then multiply by, we should also get rid of these minutes. So minutes on top, then seconds down. So 60 seconds give us what? 1 minute. So at minute disappear this hour, and that hour will disappear. So this will be equal to, okay, this will be equal to, let's just multiply what we have everything. We can do this 0 there, and the 0 disappear. 1 0 and another 0. So we have just remained with 10, which will multiply by what? 60 and another 60. Then on top it is just 1. So we have 1 cubic meter over 60 times 60, that's 3,600 multiplied by 10. So we have 3,600 times 10. So just add another 0 seconds. So this will give us what? Let me just punch that one. We calculate. So 1 which should be divided by 3, 6 with how many zeros? That's 3. Okay, 1, 2, 3. We are getting 2.7778, so let's just round it off to 3 significant figures, which will be 2.78 times 10 to the power negative 5. So we have 2.78 times 10 to the power negative 5. Then the units, we have cubic meters over what? Seconds. That's it. We are done with that question. Okay. Then we can proceed to the next question. So the next question, which is actually question 5. So for question 5 reads, so we have a worker is to paint the walls of a square room 8.00 feet high and 12.00 feet along each side. What surface area in square meters must she cover? Then NB there, not very well, that 1 meter is 3.28 feet. So let me just read the question again. A worker is to paint the walls of a square room 8.00 feet high and 12.00 feet along each side. What surface area in square meters must she cover? So if you want, you can pause the video, then try to solve the question. After that, you get back and confirm with the solution. So this room, actually it's a square room, then the walls of the square room have to be painted. So let's assume, let me do this. We have a square like that. Okay, so let's say this is the floor. That's the floor down there. It's the floor. Then on top we have the roof there. On top we have something like the roof there. On top we have the roof. So that's a square which we have. So if this is a square room and the height of each wall is actually 8, then along we have 12 feet like that. 12 feet, 18 feet. So it means that each square is 8 by 12 feet. Each square is 8 by 12 feet. Now these walls have to be painted. So in a square room, if you imagine a room, how many walls will be painted? So we should exclude the part for the roof, and this part for the floor should be excluded. So simply count this one there, then we have 2 this side, the wall this side, the wall this side, and the wall that side. So you find that you have 2 walls facing each other, and the 2 other walls facing each other if we exclude the roof and also the floor. So you find that we have 4 squares rather. Yes, we have 4 squares. So in order to find the total area that will be painted, we have to find the area of 1 square room. So area of 1 square wall rather will be equal to, it's just, since this is a square, we can say actually this one should be rectangular. If you see the dimensions, okay, so let's just use LB. So area will be equal to 12 feet multiplied by 8 feet. So A is equals to 12 times 8, that's about 96 square feet. So 96 square feet, that is just the area of 1 surface. Then we have 4 surfaces, meaning that 96 should be multiplied by 4 so that we can cover up for all the 4 surfaces. So say total area will be equals to, it's 96 multiplied by 4, and the answer is simply 384 square feet. Okay, but according to the question, it's a what surface area in square meters must she cover? So this answer should now be converted to square meters using the chain link conversion. So let's check the conversion which has been given. So we have been given 1 meter, which is equal to 3.28 feet. 3.28 feet. So if we check we are dealing with area, then that is linear, so we should do square the conversion factor so that it can suit that area. So say squared, even this side squared. So we have 1 meter squared, which will give us, so 3.28 squared. We are getting that's 1010.7584 feet squared. So that's our new conversion factor for area. So we're getting the 384 feet, square feet, over, this one can be over 1, multiplied by, okay. So chain link conversion, we should get rid of square feet. So feet squared, then square meter should be maintained. Then simply get the conversion factor. If you have 1 square meter, we should have what? 10.7584 square feet. Then this will be equal to, so feet and feet there disappear. Then let's just divide what has remained. So we have remained with 384, we should divide by, so we have remained with 384 there, being divided by 10.7584, and that is 35.69. So we have 35.69 meter squared. That's it. That's the final answer. That's the concept. So I hope you get the concept for that question. Okay, so let's move on to more questions, another set of questions. So we have 2 more questions to solve. Okay, so these are just more questions, say more questions or more examples. And if you check, I've started from what example 1 instead of saying question 6 or more. Okay, so question 1, solutions this side. So you should pay particular attention to these questions. If you want, you can pause the video, try to solve, then get back to it. Okay, so question 1, a furlong is 220 yards, a mile is 1760 yards or 1609 meters, and a fortnight is 14 days. So those are conversion factors which have been given. Okay, so in 2022, the Zambian track and field sprinter Muzala Sam Konga won a gold medal at the 2022 Birmingham Commonwealth Games when he represented Zambia in the 400-meter race. His average speed was 8.96 meters per second. Express his speed in kilometer per hour, kilometer per minute, mile per hour, furlong per fortnight. Okay, so we have been given the speed, so we can say, oh, this 400-meter race 2022, that's not even necessary. So just concentrate on 8.96 meter per second. That's the speed, and those conversions given there should do pay particular attention. So let's check. We have been given the speed of 8.96 meters per second. So I can write this as meters over 1 second, and it should be converted to what? Kilometer per hour. So meters there should be converted to kilometers, then seconds into hours. Okay, so the first one is quite direct, meter per hour. So say multiply by, so we should get rid of the meters there and introducing hours. So rather we should get rid of meters and introduce kilometers. We know that 1 1000 meters should give us 1 kilometer. Okay, then for the seconds, we convert from seconds to minutes. So second, minute, we'll say 60 seconds, it's 1 minute. Then from minutes to hours, so we have minutes on top and hours down there. So say 60 minutes give us 1 hour. So minute and minute will cancel, meter and meter will cancel. Okay, meter, then second, even this second. So just multiply what we have on top over what we have done there. So we have 8.96 multiplied by 60 multiplied by another 60. The answer which we are getting divided by what we have done there is 1000. So divided by 1000. We are getting 32.256. 32.256. So it's 32.256. It's kilometers per hour. So for the first one, we have converted just like that. Then B. So we should convert the speed to kilometer per minute. Kilometer per minute. Okay. So if we want, we can start with this same one, or we continue with this one. We have kilometer per hour. We can just convert the kilometer per hour to kilometer per minute. It will be easier that way. So we can just get 32.256 kilometers over 1 hour. Remember, it's one value we're dealing with. If you want to, we can get the same one, do the conversions, or this one, do the conversion. So let's convert into kilometer per minute. So we already have kilometers. The aim should just be changing hours into minutes. So on top, we should have hours down there, minutes. So that will have 1 hour giving us 60 minutes. And this will give us, so 1 hour, disappear. So just divide what we have there. So we have 32.256 divided by its 60. And that's 0.5376. 0.5376, 0.5376. It's kilometer per minute. If you want get the same speed in meters per second, do the conversions, you confirm with this one, find that you get the exact same answer. Okay. Then the second one is mile per hour. Mile per hour. Okay. So for mile per hour, if you want again, you can choose any value, this same original value or this value, so that you can convert it into mile per hour. So let me choose this one. I know there is already hour there. So I'll say 32.256 kilometers over what? 1 hour. So I already have hours. So my aim is to convert kilometers into miles. So we'll say multiply by, let's get back to the conversion factor. Okay. So a furlong is 220 yards. A mile is 1760 yards or 1609 meters. So we first deal with what? 1 mile. So a mile, simply 1 mile is 1760 yards or simply 1609 meters. So simply 1 mile is 1609 meters. So we can first convert the kilometers into meters, then meters into miles. So say first converting kilometers into meters, then meters into what? Miles. Okay, so we use 1 kilometer, which is 1000 meters. So kilometer and kilometer would disappear. Then multiply by, we convert now the meters into miles. So let's check. The conversion factor is a mile is 1609 meters. So what you do, we want to get rid of meters. So meter and meters that they can cancel. Then mile on top there. Okay, then we have been given a mile, so 1 mile is 1609 meters, so that meter and meter can disappear. So just multiply what we have on top over what we have down there. So 32.256 multiplied by 1000, we just have 32, then 256, that's mile, over down there, that's 1, another one, that's 1609, so just have 1609 hours. And the answer final, let me just punch that on a calculator. So we have 32, so 32256 divided by 1609, that we get. That's 20.0. So let's just get it as 20. Okay, so 20 mile per hour. So we have 20 miles per hour. We have converted. Okay. Then for D, the last one, under this question, we should convert the speed into what? Furlong per fortnight. Convert the speed into furlong per fortnight. Okay. So according to what we have there, a furlong is 220 yards, and a mile is 1760 yards. So here you have 3 options now to choose from. So we can use this one, we can use this, or even the initial value we started with. The answer should be the same. I'll choose this one, which is 20 mile per hour. So you can choose any value and do the calculations. Multiply by, okay, so let's check. We should convert the miles into what? Furlong. Then the hours into fortnight. So let's get back to our conversion factor. Let's start with the miles to furlong. So a mile is 1760 yards. Then a furlong is 220 yards. So meaning we should first convert what? Miles to yards, then yards to furlong. Okay, since we have a mile, which is 1760 yards, so it's better we convert miles to yards, then from yards to furlong. Okay, so a mile is 1760 yards. So we should get rid of miles there. So say mile, then you have to remain with yard on top there. Okay, so a mile, if you have 1 mile, according to the information given, it is 1760 yards. 1760 yards. So that mile and mile can disappear. Then this yard should be converted to what? Furlong. So we have a furlong is 220 yards. A furlong is simply 220 yards. So we have to get rid of the yard. So say over yard, then you should have furlong like that. Okay, then on top we say, let me check, a furlong, so meaning 1 furlong is 220 yards. So if we have 1 furlong, it is simply 220 yards. So yard and yard disappears, we have remained with furlong. So we have converted the yards to furlong. So the hours now to fortnight. So we'll continue multiplying. So what conversion factor are we using? Okay, so and a fortnight is 14 days. A fortnight is 14 days. So what does this imply? We just have to convert the hours into days first. The hours will be converted into days. So we know that we want to get rid of hours. So say hour on top, then day down there. Okay, so we know that if we have 24 hours, we'll end up having 1 day. So that hour and hour will disappear. Then you say multiply by, want to get rid of day, introducing fortnight. So according to the information given, 14 days is giving us what? 1 fortnight. So that days and days would disappear. Then you simply multiply what you have remained with on top over what you have done there. So what have we remained with on top? So you can see we have 20 multiplied by 17 is 60, multiplied by, that's just 1, multiplied by 24, multiplied by 14. So that answer, let me just write it. So we have 1182720 over, so what is remaining, what units are remaining on top there? It's just that fell on. Over, we have remained with what? It's 220 fortnight. So 220 fortnight equals, so the answer should be multiplied, divided by 220, which is giving us 53,760. So 53760 fell long per fortnight. So that's it, that question. Just to make sure you go through again in case you are doubting somewhere. Okay, then we can solve the last question. Question 2. So for this question we are saying astronomical distances are sometimes described in terms of light years. Then a light year is defined as the distance that light will travel in 1 year. How far does light travel in 1 year? Okay, so in this case we should know the speed of light. So we are just dealing with the speed of light in this case. So we know that the speed of light is 8 times, sorry, not 8, it's 3 times 10 to the power 8 meters per second. So in 1 second, let me explain this, 3 times 10 to the power 8 meters per second. In 1 second, in just 1 second, light travels 3 times 10 to the power 80 meters. That's the meaning of this expression. Now according to the question, you're saying, how far does light travel in 1 year? If it travels this distance in 1 second, how far can it travel in 1 year? So what does this imply? We are simply converting from what? Meters per second to meters per year. This is what it implies. So we have 3 times 10 to the power 80 meters over 1 second. So the meters should be what? Shouldn't be tampered with. Then we should convert the seconds into years. So from seconds we know we can have seconds being converted into what? Minutes. So 60 seconds will give us 1 minute. Then multiply by minutes can be converted into what? Into hours. So you can see we have 60 minutes over 1 hour. Okay, so that minute you cancel, second you cancel. Then we have hours there. Remember the aim is to end up having time in years. Then multiply by hour should disappear over what? From hours we can go into days. So we know that if we have 24 hours, we have a day. So if you have 24 hours, we have 1 day. So hour and hour disappear. Then from days we can move on to years now. We know that so we should get rid of the day there and remain with what? Year. Okay, so we know that 1 year is the same as what? 365.25 days. 365.25 days gives us a year. So that is the chain link conversion we have used from seconds to years there. Day and day will disappear. So let's just multiply what we have remained with on top there. So we have remained with 3 times 10 to the power 8 multiplied by that 60 multiplied by, so we multiply by what, another 60. What else? Can see multiplied by 24. From 24 multiplied by 3 is 5.25. That answer, what do we have down there? Just have 1, 1, 1, everything 1. So meaning the answer is 9.46728 times 10 to the power 15 times 10 to the power 15 what? Meters. This is the speed of what? Light in 1 year, meters per year. So this is the speed of light in meters per year. Then how far does it travel in 1 year? You can just write, say, 9.46, or to round off this one, let's say 9.47 times 10 to the power 15 meters. So this is how far light travels in 1 year. Okay, so that's it for this video. See you in the next video. Hope you have understood.